And now it is my pleasure to introduce our first keynote speaker, Dr. Joseph Graves, Jr. He is a good friend and a colleague, and many years ago when I first came to the University of Maryland, Dr. Graves actually gave a talk at one of our conferences, so we welcome him back and so glad that he could join us today. Professor Joseph L. Graves, Jr. is Mackenzie Scott Endowed Professor of Biology in the Department of Biology at North Carolina A&T State University. He received his Ph.D. in Environmental, Evolutionary, and Systematic Biology from Wayne State University in 1988, and in 1994 he was elected a fellow to the Council of the American Association for the Advancement of Sciences. It didn't take him long to become well recognized with his scholarly pursuits. His recent honors include Genius Award, Liberty Science Center, and Outstanding Alumnus Award, Public Service from Oberlin College. His research focuses on the evolutionary genomics of adaptation, and he is the director of Genomic Research and Data Science Center for Computational and Cloud Computing. And you can get the other details of what he does if you go to our website and look at his full biography. He is the author of many books. I will read the titles: A Voice in the Wilderness, Racism, Not Race, Principles and Applications of Antimicrobial Nanomaterials, The Emperor's New Clothes, and The Race Myth. He has also served as Racial Reconciliation and Justice Commission and COVID Vaccination Task Force of the Episcopal Diocese of North Carolina, and as science advisor to several theological seminaries. The title of his talk today is Racism, Not Race. It is with great pleasure that I welcome Dr. Graves.
Thank you, Dr. Mahmoudi, for that gracious introduction. And I hope I will not disappoint after all of that. So let me share my screen, which of course is on the wrong slide. Okay, but we will okay, so so you know the title, Racism Not Race, answers to frequently asked questions, and you have some idea who I am. But I wonder how many of you in the audience recognize the moment we are in right now, which I honestly must say that in my wildest imagination, and some of you know that I have very wild imagination, I honestly never imagined that this nation would be where it is now. We are in a full-on assault on reason and critical thinking, as illustrated by this memorandum, which came from the acting Assistant Secretary of the United States Department of Education and Office for Civil Rights on civil rights on February 14th, 2025, where it starts with comments like educational institutions have toxically indoctrinated students with the false premise that the United States is built upon, quote, systematic and structural racism and advanced discriminatory policies and practices. Now, to state that the United States, that is a false premise that the United States is built upon systemic and structural racism, would be like a member of the administration saying that the earth is flat, or conversely saying the earth is not spherical. It would be like a member of the administration saying that gravity is a myth. But yet there has been no massive public outcry against this blatantly and patently false statement by a member of the current administration. That is how outlandish this statement is. Now, there are only decades of scholarship demonstrating systemic and structural racism as it operates in the United States. Now, in today's talk, I'm only going to touch on a small portion of that scholarship, but for someone in the presidential administration to make such an outlandish, crazy statement should leave everybody in this audience gasping for air. But it doesn't stop there. This is a report from Senator Ted Cruz's Senate committee, which came out in December of 2024. The Commerce, Science, and Transportation Committee claiming that the National Science Foundation was dominated by division and extremism ideology, which they called DEI, standing for Diversity, Equity, and Inclusion, claiming that the Biden-Harris administration had, quote, politicized science, as if science hadn't been politicized a long time ago. Again, as this talk will demonstrate. Okay. And we have seen members of this administration, the president himself, blaming diversity, equity, inclusion for the airline crash in Washington, D.C., okay, in January. Members of his administration have also blamed the wildfires in Los Angeles County, not on climate change, on prolonged drought, but on DEI as well. I've considered, writing an essay describing how DEI was likely the likely cause of the death of the dinosaurs, but I just haven't gotten around to writing that essay yet. Now, in conjunction with this assault on reason is this administration's attempt to shatter the National Science Foundation, which of course makes sense. If you want to create a population that has no capacity to understand the natural world around it, then certainly dismantling the National Science Foundation is a way to achieve that. So now, setting the stage for the moment we're in, for those of you that don't know me and the way I think about science, you can get a good introduction to that in my last book, A Voice in the Wilderness, which describes, how I became the world's first African-American evolutionary biologist, how I got there, and how I think about these issues now, particularly focusing on my fight with scientific racism, on fostering the dialogue between science and religion, and on the research I'm doing in genomics, as well as how science can contribute to social justice. Now, I began to think about why and how people thought racially in our society in the early 1990s. My first book on the subject was The Emperor's New Clothes, which came out in 2001, followed shortly after by The Race Myth, which came out 3 years later in 2004. Now, The Emperor's New Clothes is a history of racial thinking in the Western world. The Race Myth continues to describe the ongoing pathology in American society because of false understandings of race, and assumes that you knew that history. And honestly, after The Race Myth came out in 2004, I really never thought I would have to write another book on this subject again. And that's because the answers to these misconceptions are so apparently and abundantly clear, especially based upon the science of the latter portion of the 20th century. But in 2019, my good colleague, Dr. Alan Goodman, former president of the American Anthropological Association, approached me to write another book in question-answer format to address the ongoing misconceptions about race in modern society that had not been solved. And I agreed that we should do that. And the book now has received strong reception, including being named one of the best nonfiction books of 2021, and just recently winning the W.W. Howells Award for the best book in biological anthropology, awarded by the American Association of Anthropologists in 2024. Now, but racism is like a hydra. So the work hasn't stopped with those books. And here are some recent publications that I bring to your attention that are worthy of a read. Also, coming out later this year, 70, Why Medicine Gets Race Wrong, the Harm It Causes, and How to Fix It, which will be published by Columbia University Press in probably late summer, early fall of 2025. The book Anti-Racist Medicine has actually been pushed off to next year, so that won't come out until 2026. So this is my good longtime colleague, Dr. Alan Goodman, who is a biological anthropologist. He's currently at Hampshire College in Amherst, Massachusetts. He is affiliated with the Escuela Nacional de Antropología y Historia in Mexico City. He has a number of accolades over his distinguished scientific career. I also want to recognize one of my newfound colleagues, Dr. Andrea Dayrup, who has been a fearless contributor to taking down racial medicine. She was actively involved as an editor of the 11th edition of Brahmans and Kumar's Basic Pathology. She called me on as a consultant in this work, and we did a really solid job of removing most of the racial medicine in this book, which was rife with misconceptions. At least the 10th edition was. The 11th edition is a great improvement. We've also published on this in leading medical journals over the last couple of years. So, Racism Not Race was designed to give folks concise and accessible answers to questions about race and racism. Now, we had put together these questions from decades of conversations with students, educators, policymakers, friends, and family. And we wanted to write a book that would allow people who were working towards human equity, but were nervous about saying the wrong thing. And in many cases, we found that those two groups overlap. Okay. And we wanted to give them the tools to be able to deal with this ongoing confusion concerning the meaning and significance of human biological variation in relation to several several issues within our society, including particularly from where I sit with regard to disease predisposition. So for my talk today, the most relevant chapters in R&R are Chapter 1, Chapter 3, everything you wanted to know about genetics and race, Chapter 5, why do races differ in disease incidence, and Chapter 6, life history, aging, and mortality. Now, clearly, there's a lot more in this book than these 4 chapters, and I recommend for those of you that have not read it that you do, because it really is path setting. So now let's go back to the thing that brings us all here today. Okay, so you will often hear scholars in the humanities and social sciences make the statement, race is not a scientific concept. Now, I feel that this statement is inaccurate, and it's inaccurate because it fails because it conflates 2 very different concepts. The biological race concept, which I discuss in the Cold Spring Harbor Symposium of Biology article that I wrote last year called Favored Races in the Struggle for Life, the biological race concept has a different intellectual history than the socially constructed and socially defined race concept. They really should not be confused with each other. And that biological race concept has gone through several stages in its development. In the earliest period in which the biological sciences were being founded in the Western world, it relied on physical features, or what we would call the phenotype. But in the 19th century, it shifted to geographical location. And I want to point out that the 18th and 19th century conceptions of race that dominated thinking in the Western world were driven by their allegiance to Christian theology, not to biology as we understand it in the late 20th and the 21st century. This is something that most people do not understand at all. It only becomes associated with the modern scientific enterprise in the 20th century, and there where it shifts from geographical location to population-based gene frequencies associated with the neo-Darwinian synthesis of the early 20th century. And then later in the 20th century, an additional criterion is added due to the development of the discipline of phylogenetics, and as to whether any group within a species can be considered a unique evolutionary lineage. Now, the other thing I'm going to say about the biological race concept is that this is something that can be applied to and has been applied to virtually any species with biparental inheritance. It is not something uniquely deployed to understand human biological differentiation. However, socially constructed and socially defined race is entirely focused on humans. And it arbitrarily utilizes aspects of morphology, geography, culture, language, religion, but only does so in the service of a social dominance hierarchy. It was created for that purpose and that purpose only. So the reason that Alan and I chose the title Racism, Not Race for our last book was we wanted to drive home the point that our modern understanding of race as we live it in Western, and I would now say global societies, was driven by the historical processes of colonialism, slavery, and genocide. It was never about an objective examination of the biological variation within our species and then grouping people into logical, biologically based groups. The social construction never had really anything to do with that. It was all about social dominance hierarchy. Now, from what I've just said, we should recognize that our species, anatomically modern humans, does not contain biological races. We do have geographically based genetic variation. That is certainly true. But people confuse geographically based genetic variation with the existence of legitimate biological differentiation within our species that we would call race. That is not true. So in the short time I have with you, I'm going to demonstrate why that's not true and how it is particularly harmful, particularly in this case, using the example of medicine, but I could use many other examples. For example, in 2002, the same year the human genome was published, this op-ed appeared in the New York Times. Sally Seitel, who was a member of the American Enterprise Institute, said, "In practicing medicine, I am not colorblind. I always take note of my patient's race. So do many of my colleagues. We do it because certain diseases and treatment responses cluster by ethnicity." And in this statement, you already recognize the confusion that this individual has over this problem, because race and ethnicity have always had different definitions. They're not the same thing. So it's unclear what exactly they mean when they're talking about the clustering of certain diseases and treatment responses. Now, if she were the only person that suffered from this misconception in the medical community, then the problem would not be as massive as it is and wouldn't have required me to write this new book on what this problem is, where it came from, and how we must take immediate action to fix it. But here is a paper or data from a paper that was published in the Proceedings of the National Academy of Sciences in 2016 with first, second, and third year medical students at the University of Virginia, which is one of the nation's premier medical schools, as well as their residents. And these false beliefs, for example, blacks age more slowly than whites. This false belief was held by 33.3% of first-year medical students, 38.9% of second-year medical students. It drops to 20.3% in the third year, but was held by 50% of the residents at that medical school. And I'm going to choose another one. Black skin is thicker than white skin, 63.5% first-year med students, 58.3% of second-year med students, 37.3% of third-year med students, and 100% of their residents. Now, I can tell you from work that I've done with Dr. Dayrup over the last 3 years, we've spoken at close to 80 of America and Canada's premier medical programs, as well as medical testing boards, and found that these misconceptions are rife amongst the physicians that we've spoken with over the last couple of years. Now, you can only do this if you've been out of touch with the developments in population and evolutionary genetics over the 20th century. So, for example, even by 1974, one of the architects of that work, Ernst Mayr, said the concept of subspecies is fallacious. Now, Mayr equates subspecies with biological race in this book. Species are not composites of uniform subtypes or subspecies, but consist of an almost infinite number of local populations, each in turn in sexual species consisting of genetically different individuals. The difficulties of the subspecies concept are intensified if one considers the subspecies not merely as a practical device of the taxonomist, but also as a unit of evolution. The better the geographical variation of the species is known, the more difficult it becomes to delimit subspecies, and the more obvious it becomes that many such delimitations are quite arbitrary. Now, that really applies to human beings. Turns out that we can't accurately classify human beings by either physical criteria or genetic criteria. For example, this tree of relatedness, which was published by Luca Cavalli-Sforza and A.W.F. Edwards in 1964, shows that if you use physical traits, you misgroup human populations based upon their evolutionary history. For example, I don't think anybody here would doubt that Swedish and French people look more like each other than they do people that were described as Eskimo or North American Indian. But that Swedish and French people actually look more like the Eskimo or North American Indians than North American Indians look like South American Indians should give you pause. Or when we look on the other branch of this tree, which places Papua New Guineans and Australian Aboriginal people with sub-Saharan African Bantu-speaking people on the same branch, that also doesn't match our evolutionary history, because sub-Saharan African Bantu language-speaking people are actually closer to Europeans in their genetic ancestry than they are to Papua New Guineans and Australians. So this picture on the right, which I show to my classes without the identifying caption below, I asked my students, where do you think this individual comes from? They will almost uniformly all say Africa. Well, this person is not African. They're from the Solomon Islands in Micronesia, indicating again that physical appearance is not an accurate descriptor of genetic relatedness or evolutionary history. Now, we can see this also when we look at skin color distribution across the globe. And basically, what you would expect is that people who live in the tropics have darker skin than people who live in the temperate and Arctic zones. And that's exactly what we find. But if we look at patterns of human migration, okay, people first in those ancient migrations moved through the tropics and began to genetically differentiate in the tropics before they moved into the temperate zones. Even though, as I pointed out, that the populations in the sort of central portion of the world in the temperate zones are more related to each other, even though they have different skin colors now, than they are to people in Australia, New Guinea, or Micronesia. So now, to make this point even more powerfully, the last map is a Mercator projection, which basically exaggerates the land masses towards the poles. And so Greenland and Northern Asia and Europe are much bigger in the Mercator projection than they actually are. And for this reason, you can see that Africa, in fact, passes through the greatest amount of latitude of any continental mass on the planet, which explains why there is more skin color variation on the continent of Africa than in all of the rest of the world. Now, we also find that these physical traits are not correlated with each other. For example, we find blonde hair in Europeans and Melanesians, and the Melanesian blonde hair gene is actually older than the European blonde hair gene, which is less than 6,000 years old. So when we attempt to deploy biological criteria for race in humans, those criteria fail. And those criteria now are variation within versus between groups, or whether any group within the human species can be considered a unique genetic lineage. Now, let me demonstrate this quickly. For those of you who have not studied population genetics, these are the forces on the left-hand side of this table that account for the variation in allele frequencies we see within any species, including humans. Now, the two biggest ones are natural selection, which is the only factor that accounts for adaptation within a species, that is, traits that improve the survival and reproduction of the individuals within that species, and genetic drift, which occurs at random due to fluctuation in population size. And genetic drift doesn't have to be adaptive. In fact, oftentimes genetic drift can cause higher frequencies of disease-causing alleles. However, the most significant contributor to the genetic variation that exists within our species is not natural selection, it is genetic drift. And that is because of the way our species moved around the globe in serial migration events of small population size. Now, we can measure the amount of genetic diversity within and between groups within a species by looking at the heterozygosity of loci within their genomes. I'm going to try to explain this quickly because I know not everyone on this call has taken courses in genetics. But basically, with biparental inheritance, you can have 3 genotypes at any given place in the genome. People who share the same allele given by their parents. Now, in this case, we're going to say that, we're going to use dominance here. We don't have to. So those 2 people, or that person has a gene that's dominant from both their mother and their father. Or you can have an individual who received two recessive genes from both their mother and their father. Okay, that's homozygous recessive. Or you can receive a dominant from one of your parents and a recessive from the other. We call those individuals heterozygous. So to measure genetic diversity within a species, we actually look at the heterozygosity. And this equation here allows us to do that and to ask the question, is that heterozygosity of its subgroups equivalent to the heterozygosity of the total species? If it is, then HS and HT equal, and the FST statistic is 0. And what that essentially says is that you have one large panmictic interbreeding population that hasn't differentiated in its allele frequencies over the entire range of the species. So you could not use the idea that that species has biological races, because pretty much the allele frequencies in every group within the species are the same. Now, if HS were 0, okay, that means that the subpopulations had gotten rid of all of their genetic diversity, then HT over HT would be 1. And then you would say you definitely have strong differentiation between the subgroups within that species. And you would legitimately say, yes, we have biological races or subspecies. Now, clearly in the real world, we never get 1, we never get 0. So Sewell Wright, the person who invented this statistic, settled on the value of 0.250, or 1/4 of the way, as indication of very strong genetic divergence within or between the subpopulations. And after that value, you would say, okay, we probably have biological races here. So the good news is that we've measured this for human populations. And guess what we find? When we do that, we find that human FST is actually quite low. So if you compare human FST, as this study did in 2002, to other large-bodied mammals, ours is about 0.156 based upon this study, which only looked at 24 genes. But you can see to the right of humans, things like elephants in southern Africa, white-tailed deer in the US, Grant's gazelle in Kenya, gray wolves in North America, they all have very strong FSTs in excess of 0.5, 0.6, 0.7. So for those species, we would be legitimate in saying, yeah, these species have biological races. But our species, anatomically modern humans, does not. Now, this was before we had access to tools like next generation sequencing. So once we have this tool, we can look at far more genetic markers for genetic difference between and within human groups. And when we do that, we find that human FST is even smaller than we thought, particularly in regions of the genome that actually encode proteins and therefore are acted on by natural selection. But we still don't get numbers anywhere near Wright's critical threshold of 0.250. It gets higher when we look at regions of the genome that don't encode proteins and are therefore determined by genetic drift, which is random. And in fact, if you're asking the question, Dr. Ray, well, if humans don't have biological races, then how do these DNA ancestry companies tell me that a certain percentage of my genome is from Europe and another percentage from Africa? Those algorithms are working on these non-coding regions, which give a greater signal of divergence and weren't acted on by natural selection. Now, if we look at FST with distance between human populations, it essentially tells us that populations that reside closest to each other share more of their genome in common and therefore have lower FST values. But as you move apart and compare populations pairwise, and this is the lower panel, okay, you get larger amounts of FST. So populations that are 30,000 kilometers apart will show FSTs approaching Wright's value. But as we go through the geographic distance in which human populations reside on the planet, we see continuous change in genetic distance, meaning that human genetic variation is continuous, not discrete. Therefore, the idea that you could separate out particular places in human genetic diversity and say, oh, this is where one race begins and this is where another race stops is ludicrous. Absolutely not possible. Any such delimitation, as Meyer said in the 1970s, would be arbitrary. Now, furthermore, in our ancient migrations across the globe, there really wasn't that much genetic adaptation that occurred in modern humans. So if we look at the things that do show signals of strong adaptation, there are things that you might suspect would have to be true. For example, skin pigmentation. Skin pigmentation shows evidence of strong divergence. But what I'm going to tell you is that that divergence occurs relatively late in our history. Okay, for example, for the last, until the last, or I'm saying it backwards. Europeans, for example, don't have fair complexion until about 3,000 to 6,000 years ago. So that means that when they first arrived in Europe 45,000 years ago, they had dark complexion. So the evolution of fair complexion in Europe and Eurasia is something that happened much, much later. So we have adaptation to altitude. And that occurs in East Africa, occurs in the Himalayan plateau, it occurs in the Andes plateau. It would make just as much sense to say, biologically, that we have two great races in our species. High altitude people, Andeans, Himalayans, and Ethiopians, and low altitude people, everybody else. Or we could say, oh, we have two great races in our species. Those who are adapted to malaria, which occur in Africa, Southern Europe, the Middle East, India, Indochina, and those that aren't adapted to malaria, and so on. Because there really hasn't been that great amount of genetic adaptation in our species. And if you look at the number of traits listed on this slide, it's basically 12. And each one of the symbols associated with the traits are single gene locations, somewhere around 30 to 40. But our genome contains 19,000 protein coding genes. So to think that the minor physical differences that we observe in modern humans are in fact real evidence of adaptation, again, is ludicrous. Okay? And again, we can show that these geographical adaptations like that to malaria do not match our historical, socially constructed ideas of race. You see thalassemia in Africa, in Europe, in the Middle East, in India, all the way into Indochina and New Guinea. Okay, you can see HBS, sickle cell S disease, in Africa, in Southern Europe, in the Saudi Peninsula, in India. So these genes do not define biological races, okay? And if we look at the frequency of HBS, we find HBS frequency is higher in Greeks than it is in African Americans, or higher in Greeks than it is in South Africans. Once again, indicating it's an adaptation to malaria, not an indicator of racial membership. Now, one of the other things, of course, when we say that races were created by colonialism, genocide, and slavery, was the fact that the populations of the Western Hemisphere, the ones that currently reside in the Western Hemisphere, were precisely a product of those social forces. For example, African Americans, who here are defined as persons who are descended from enslaved people in the Western Hemisphere, have a mean European ancestry of about 16%. But depending upon which portion of the nation you're talking about, those populations can have European ancestors as high as 30%, as they do in West Virginia or Washington State, or lower than that, as they often do in the southeastern United States. And if we look at people who are defined ethnically as Latin American, their ancestry profiles differ dramatically as well. Since the only thing that unites these groups ethnically is whether they speak Spanish or not. For example, in Puerto Rico, the ancestry profile, and this is the average ancestry of the nation, not of a given individual, is 72% European, 12% African, and 16% Amerindian. In Mexico, however, it's 51% Amerindian, 46% European, and only about 3% African. In Peru, it's 80% Amerindian, 18% European, and 2% African. And in Colombia, 64% European, 25% Amerindian, and only about 7% African. However, within any of these countries, there are groups that are essentially either all indigenous or all African. For example, in Chocó, a state next to the regional capital of Medellin, Chocó was the site of gold mining and saw the importation of large numbers of enslaved Africans to accomplish that. And so their genomic profile, ancestry profile, looks very much like that of African Americans in being over 80% African, but a much higher percent of Native American ancestry than you would find in African Americans. So again, these populations are the result of colonialism, of genocide, and of slavery, okay? Not natural biological units within our species. Okay, now, so I want to end by underscoring these points. Humans do not have biological races, but yet we do have clear examples of disparities associated with socially defined race, such as heart disease, cancer, influenza, okay, septicemia. Now, we can ask the question then, why are there socially defined racial disparities in health disease, in health and disease? And to understand that, we have to know something about quantitative genetics. And for quantitative traits that are determined by many genes, we understand variation in that given trait by the combination of genetic effects, environmental effects, gene by environment interaction, the covariance of genes and environment, and whether the trait is being measured accurately. Now, if we look at most of the diseases for which we measure health disparity, genetic effect is small, whereas the environmental effect is large. The gene by environment effect is large. The covariance of genes and environment is large. And depending upon what the trait is, the error can be unknown, and in many cases large. So, does it make sense then that Africans or persons of African descent should have greater disease burden in the United States compared to Europeans? Well, if we were going to go on the basis of a genetic effect alone, it turns out that there's more bad genetic variation in Europeans than there is in Africans. Now, this study, which was done in 2008, looked at two types of genetic variants in the genome. That which was possibly deleterious and that which was probably deleterious. So when we looked at the variants that were possibly bad, there was no statistical difference between Africans and Europeans. But when they looked at those that were probably bad, it turns out that Europeans actually had a higher burden of these probably bad genetic variants compared to Africans, which means that the health disparity profiles we see in US society are actually opposite. In other words, if genes were telling the entire story, we would expect European Americans to have a higher burden of disease and African Americans to have a lower burden of disease. Now, you could say, well, Dr. Graves, this is an old study. It was done in 2008. There really weren't that many individuals involved. So, really can't take that to the bank. Well, let's take a look at a recent publication that came out last February in 2024, sorry, which looks at now 245,000 whole genome sequences. And this was data brought together by the All of Us research program at the National Institutes of Health. And when we look at these 245,000 whole genome sequences, guess what we find? We find once again that people of European ancestry actually have more likely pathogenic clinical variants than African Americans do. So this matches the earlier, smaller study. So once again, we're left with this conundrum. How is it that European genomes have greater pathological genetic variants in them, and Africans have lower pathological variants, but the health disparities go the other direction? Okay, so finally, here is what the ancestry profiles in this 245,000 genomes looks like. The diagram on the left-hand side by socially or self-identified race, again, shows that most of the people in the survey were European, but 51%, sorry, it's actually the other way around. It's like 49%. So Europeans were the largest group, but of the samples, 51% were non-European. And what we see again is that if we look at the ancestry profiles of these individuals, they're not all one color. So people, Asia, have ancestry profiles that are East Asian, South Asian, West Asian, Black or African American, have European, have African, have West Asian, okay, Hispanic or Latino, Amerindian, okay, European, African, and so on. So this idea that individuals belong to these discrete biological groups is just not supported by modern data. Now, this is now becoming the consensus of modern researchers in the field, so much so that the National Academy of Sciences, Engineering and Medicine published a report on the use of population descriptors in genetics and genomics research in 2023, in which it essentially says that you can't use socially defined race to solve genetic problems. I testified before that committee on April 4th of 2022 and stated our social conceptions of race and ethnicity do not match the underlying biological and genetic variation within our species. And we should never confuse the things that were created for the purposes of oppressing people with the nature of that biological and genetic variation. So also asked to write a report for Nature Human Behavior in 2024, in which I summarized the recommendations of that National Academy of Sciences report. Okay, and here are the main points. Socially defined races are not biological entities. That you cannot use race as a proxy for environmental factors. Okay? You must include environmental factors in study design. You must engage the communities who are the subject of the research across conception and implementation of your studies. You must select and use population descriptors in genetic and genomics research more effectively. And then finally, you need to be accountable for the implementation of the population descriptors you use in your study. So I'm going to end my presentation here, and I'm happy to take any questions.
Thank you so much, Dr. Graves. Boy, you've given us a lot to think about and much that we need to really explore and look into more deeply for those of us who are not from a genetics background. Okay, we are now ready to receive the questions from our audience. If you would go to the Q&A and please write your question, we would be happy to address those and Kate Dr. Seaman will moderate the Q&A for us. Thank you.
Thank you, Hoda. The questions are still loading from the audience, so I also want to let the panelists know they can add their questions in the Q&A box or also in the chat. And then I'm going to steal this time to ask a question myself, if that's okay, while we wait for others to come in. So I wanted to come back to what you were talking about in the medical schools and the statistics you were talking about. And the racialization of patients in particular. And one of the things I was wondering is, what do you think we have to fundamentally change in medical education to change these approaches? But does it have to start kind of earlier than that? Because obviously medical school is kind of the end of a series of training that students go through. So where do the interventions need to start to kind of change these approaches?
Oh, well, Kate, luckily, I just wrote an entire book on that subject. So let's start with an essay I wrote back in 2002, why we should teach our students about race. Okay. And we need to be teaching human biological variation in high school. Okay. As part of human biology. Kids clearly have questions about why do I look different from somebody else? Okay. And they're inculcated in a racist, racial society. So to leave these kids as they're growing up in middle school and high school without answers, without scientifically valid answers to what they clearly see in front of them, it's basically malpractice. It's educational malpractice. But it's educational malpractice, which again has a history. This society has adamantly opposed teaching solid biology to high school students. In part because, one, to understand human biological variation, you have to really understand evolution. And many states don't want students learning evolution. Much of the movement towards school vouchers to allow kids to go to private or charter schools, to take them out of public schools, is actually to get away from teaching basic science such as evolution and then giving them some unsatisfactory explanations for what they clearly see around them. So yeah, it needs to start in high school, and there's really good work by people like Brian Donovan about how you can teach these topics responsibly in high school texts and in high school classes. It needs to happen in the university. It should be part of general education. And the way I've always approached it in gen ed is teaching critical thinking and using an example of human biological variation as an example of how to deploy the tools of critical thinking and scientific reasoning. Because now you can't teach that in many regions of the United States because it will be called DEI woke ideology, as Ted Cruz has identified one of my research grants as being. So the way to do it now, and the way we should have always been doing it, is this is an example of how we teach critical thinking, scientific reasoning, and here's an example to deploy it to: human biological variation. Then when they get to medical school, that should be a first-year course. Okay. Biological variation, biological anthropology as relevant to medicine should be a first-year course in medical school. And of course, many medical schools, whenever you ask them to deal with their curriculum, they will respond, "Oh, we have so much stuff in the curriculum already. We can't add new material. It's just too much." And the answer is no. It's a question of what you value. If you understand that these racial misconceptions are harming patients, and they are, then you need to teach this in first year medical school, as, by the way, my good colleague, Dr. Andrea Dayrup, does in Duke University's pathology course, first year pathology course. They address this material. So this clearly can be done. So the answer to your question, Dr. Seaman, is that we need to do this at all levels, because race and racism is such a toxic misconception in American society, and it has to be eroded with sufficient educational effort.
Absolutely, thank you. So we have a bunch of audience questions now. So the first one comes from Bobby Colehouse. What do you think is the reason for the increased variation in Europeans compared to Africans?
Okay, so it's actually not increased variation. It's the other way around. Okay, the vast majority of genetic variation in the human species is found in Africa. And the reason for this is simple. Okay, our species first evolved in Africa around 300,000 years ago. The mutation rate in the human genome is essentially constant. Okay, so a population that's been in the same place for a longer period of time, just by mutation rate alone, is going to have more genetic variation. Secondly, the populations that left Africa underwent founder effect and genetic drift, which means during the migration, ancient migration around the globe, those populations lost genetic variants. They didn't gain them. So you can look at genetic variability in the human species and its linear decline from Africa to the Americas. So the data that I showed bad genetic variants. And why there are more bad genetic variants in European populations compared to African Americans is probably just drift, bad luck, roll of the dice, more of these pathological variants in Europeans, nothing to do with natural selection.
Thank you. The next question comes from Malik Wilson, who says, fascinating stuff, thank you. Is it wrong for doctors to consider morphology of patients vis-a-vis potential recommendations or considerations?
Certainly, doctors should look at the morphology of patients. In fact, I just did work with Elsevier, along with Dr. Alan Goodman and Dr. Fatima Jackson from Howard University, to create a new set of 3D models of human bodies to be used to train physicians and nurses. The previous sets of 3D animations were just of Europeans. And so now we have animations of people from all over the globe. Now, it turns out that human morphology is pretty much the same. Okay, so you're not really changing, your diagnosis of any disease condition by having these models. But it does teach aspiring physicians that not everybody has fair complexion and the morphological characteristics of Northwestern European populations.
Thank you. The next question comes from Robin Morton, who asks, is DNA testing important to Black Americans?
DNA testing is important to everybody because the diseases or genetic variants associated with disease run in families, not in, quote, racial groups. So if you really want to know the likelihood that you might be carrying a genetic disease variant, what you should do is figure out what's in your family. Okay, since you inherited those genes from your ancestors. Okay, so doing that kind of testing has to be taken, however, with a grain of salt, because the DNA ancestry companies are making projections about your disease risk that are not really very reliable. And they're not reliable because they make all sorts of assumptions about disease risk. Now, some of them are pretty strong determinants, but most of them are not that strong. So yes, you certainly, if you know the potential risk variants in your genome, you have some idea. But quite frankly, I would also say that, it's not going to shouldn't really change your behavior, because the things you do to stay healthy are things you would do depending, no matter what your genome says, right? You should exercise. You should eat a balanced diet, right? You should try to get enough sleep. You should try to reduce stress, which of course is hard for us Black folks to do in America. But doing those things are far more likely to improve your health profile than knowing what your DNA is.
Thank you. And then there's a follow-up question that ties in nicely with that from Derek Conto. For people who are curious to know their ancestry, how can they go about getting accurate testing since current existing databases are outdated?
Well, I mean, you just said it, Derek, right? They're outdated. In many ways, you will know more about your ancestry by asking your family members. Okay, now, certainly, and I've been asked to endorse various products on the market in the past, and I won't do it for any of them. But, 23andMe has reasonably updated database on Western and Central Africa. Other places, not so good. But the simple thing is, you know, when you look at any of these projected genomic ancestry profiles, you're really taking them with a grain of salt because they are very much dependent upon who was sampled to make the estimate. And a lot of groups haven't been accurately sampled particularly in regions of the world like Africa. Okay, so these tests generally do better on Europeans and East Asians because more people have been tested.
Thank you. The next question comes from Lee Moavanzadeh. How much of biological study of human differentiation was driven by a desire for supporting racial hierarchy to legitimize colonialism/slavery?
That's a difficult question to answer. Okay. And one of the things I do not want to do is, as I've said in the past, lump the biological study of variation in the biological sciences with some of the physical, anthropological, ideologically driven studies of the 19th century. So if you want to go back in the 19th century, a lot of that work was solely to validate European superiority. So people like Samuel Morton, Louis Agassiz came up with theories of European superiority, and they went out and looked for data to demonstrate that Europeans were superior to all other people. However, that changed with the growth of the disciplines in the 20th century, and there was less of those implicit assumptions of European society or European populations being superior to others as the disciplines grew. And certainly by the 1970s, when people were doing protein electrophoretic studies of genetic variation, that wasn't driving them at all. And what we now have in modern genomic science isn't predominantly driven by these ideological assumptions, although they're still in there and they still need to be uncovered. They need to be challenged when we find them.
Thank you. There's two questions that are very similar, so I'm going to merge them into one for time's sake. So the first part comes from Byron Haskins, who asks, what can scientists who know there is no biological basis for racism do to change the socially defined racism built into our institutional research and government programs? And then the second piece comes from Jerry Peake, who asks, is anyone compiling indicator sets that can replace the persistent reliance and reluctance to drop race as a variable?
Okay, so the answer to that is outlined in the two most recent reports for the National Academy of Sciences, Engineering, and Medicine. So the 2023 Population Descriptors Report and the 2024 Race as a Biomedical Factor Report. Both of them give concrete examples of how we can better collect and organize data outside of the traditional social definitions of race that are being used and a buttressed biomedical research. And so you're in this sort of conundrum between knowing that these categories are not really indicating what you want in your biomedical work, but you have to use what's in the data, okay, and collecting new data and organizing it along the variables that make a difference. Now, unfortunately, under the current administration, work like that is going to be extremely difficult because, quite frankly, they are attempting to destroy any legitimate examination of human biological variation and health disparity under the misguided attempt to destroy what they call woke or DEI in science. But we still need to do the work correctly.
Thank you. And that leads nicely into the next question from Selvi Zabihi. We hear critiques of medical research being skewed because it's based on subjects who are men of European background and then generalized. How can that be addressed without resorting to racial categories that are not genetically valid?
Well, one, we can measure genetic distance between individuals. Okay, so there's a difference between socially defined racial categories and measurements of genetic distance. And in fact, both of those reports talk about looking at genetic distance. We know that people have different ancestry profiles, recent ancestry profiles. So if you're looking at a sample of people who are skewed from Northwestern Europe, you're only getting a very small fraction of the genetic diversity that exists on this planet. If you were doing the studies right to begin with, you would have started with Africa because most of the genetic diversity on our planet exists in Africa, which would have given you greater potential to find idiosyncratic variants associated with, strange things that nobody's seen before. So my answer is you can use genetic distance, and we need to diversify clinical trials. In fact, in the new book, I have a whole chapter on clinical trials and how they should be done properly.
Thank you. The next question comes from Tucci and Guangua. Even if biologically race is not that telling, is the social reality of race impactful or significant enough to understand? For example, Black women are more exposed to preeclampsia when pregnant due to the racism, social, and economic stress. How do we treat or combat that without acknowledging race and the social impacts to certain disadvantaged groups? While it may seem focusing on class is sufficient, even middle class or upper middle class Black women are more susceptible to preeclampsia.
Okay, so nothing in the talk I just gave indicates that you should not be using socially defined race as a variable in biomedical research. Okay, and oftentimes people hear my talk and they hear, oh, Graves says there's no such thing as race. I've never said that. I've said that humans don't have biological races. In fact, the paper that I listed at the beginning of the talk, which was published in Evolutionary Medicine and Public Health, on essentially socially defined race as a neglected factor in niche differentiation in humans, is a study in which we do precisely that. So socially defined race has real biological effects. Okay, and we should study it as a social variable and not conflate geographic genetic ancestry with social definitions, because there are people in those social categories who have a gambit of genetic ancestries, but who are all defined as Black, right? So Blackness in a racially subordinating society is a variable that impacts someone's health and life course without regard to their genetic ancestry. So the key is to not conflate genetic ancestry with the social definition. They are used to study different problems.
Thank you. And I think that feeds into a question that we have from Bart Lewin, who says, Dr. Graves, I'm a part-time CEO of a company that develops a medical device. We are required to collect ethnicity as part of our clinical trials. When performing our biostatistical analysis, we consistently find that ethnicity is significantly correlated with our results. Ethnicity is a mix of race and national origin in our data collection. Do you have any specific advice related to your statement in your report?
Again, I think you just made the point that I just said, right? Social definitions of race matter in terms of the things that folks are exposed to. And that goes through a gambit of things. And in all my writing, I've talked about the toxic environment that racialized persons experience in white supremacy. And those toxic environments influence health outcomes. So for example, just things like 2.5, nanometer particulate matter. People of African descent breathe more of that in because of their geographical locations in the United States. That causes all sorts of health problems down the road that differentially impact them compared to European Americans. So again, the important thing is to differentiate genetic ancestry from social definition and understand which factors are playing a role in determining the health outcome that you're studying.
Thank you. And the next one comes from Oji Iyamu. Can you please give your understanding of this distinction between ethnicity and race, and why do you think this often gets misconstrued?
Okay, so ethnicity is defined by a number of variables, including national origin, language, religion, okay? And those things clearly differ from geographical ancestry and socially defined race. You can have people in the same ethnic group that have dramatically different ancestries, such as I showed with Hispanic. When you use this is an ethnic group that's legitimated in the OMB 15 directive defining ethnicity in the United States. So we have two ethnicities, Hispanic and non-Hispanic. That makes absolutely no sense biologically. Okay, you have people who are in the same region of the world with the same genetic ancestry profiles who speak Portuguese or speak French, and they're not Hispanic. So we have to be clear on what exactly we are talking about, and how what we're talking about is influenced by or influencing the problem that you're studying, right? And these ethnicity terms, again, from the point of view of our biology, are extremely nebulous.
Thank you. The next question comes from Alex Boyson, who asks, how does the new social and political environment reframe the question of race as a social construct, and of the value of social and racial diversity compared to how questions such as these have been framed before?
Well, the new political landscape in the United States, again, first off, let's be real about this. There's nothing new here. Okay, so this is just an intensification of structural racist attitudes that have existed in this country the entire time. It's just that now somebody who holds those positions happens to hold the White House. So there's nothing new here. So, and of course, this is going to make work towards justice and equity even harder, because they are now defining such work as being racist. So this is a classical tactic of blaming the victim. Okay, people who have suffered for now centuries of structural racism are being called racist for trying to dismantle the structures of racism. It's a brilliant tactic, and and the Nazis used similar tactics when they took over Germany. So the answer I give to you all is that we must resist this insanity. That's why I started this talk out with the assault on reason. These people, okay, have no scientific legs to stand on. But not having scientific legs doesn't matter when you're in control of society. So we have to wrest that control away from them, and we have to do it quickly. And because if we do not, there may be no human civilization on this planet to rescue.
Thank you. The next question is from Dr. Sheena Mason, who asks, how do you respond to people who might see the examples you shared, like of someone from the Solomon Islands, and say that these exceptions prove the rule or something along those lines?
Well, I mean, people can say what they want to say. It doesn't make it true, right? So again, what we know is that human physical traits are not correlated with each other. It's called the principle of discordance. And it's true of numerous biometric examples in the human body, whether it be skin color, whether it be skull metrics, whether it be body proportions, adaptation to altitude, and so on. Physical attributes do not predict evolutionary genetic relatedness. So that's well known. Okay, and then recognizing that, we can, again, when we're talking about the science, we can show that that kind of reasoning simply fails. Right. And that's relatively easy to do now that we particularly have, whole genome sequencing. It costs $100 to sequence a human genome now. So that part is easy. Again, it's dismantling the connection between what people see and their assumptions about the underlying cause of what they see. That's the difficult part, not actually showing that the two things don't correlate to each other.
Thank you. And we have a question from Derek Contu, who says, moving forward, how can we redefine healthcare therapy and develop an effective practical therapeutic framework for precision medicine?
Okay, so again, I have a chapter on precision medicine in the new book. And so if we were doing medicine properly, we would understand that human genetic variation exists. And a drug that works for one group of people won't necessarily work for another group of people. And there's all sorts of work that's shown that economically, precision medicine used properly actually saves costs as opposed to adding to costs. So if the argument is, oh, we can't do precision medicine because it costs too much, that's actually not true. Precision medicine actually would save dollars with regard to dealing with things, medications that don't work properly, dealing with side effects, treatment of individuals for specific conditions. Precision medicine would help that. Now, of course, the problem is the people who are going to have access to precision medicine are going to be those in particularly Western societies who have upper, who reside in the upper portions of the socioeconomic structure, because that's going to be paid for by insurance. If you don't have medical insurance, you're not going to get precision medicine. And who has medical insurance now? The people who are employed in the upper echelons of our societies. And the way this economy and those in charge of it are running, we are going to see a greater disparity between those who have and those who have not. So precision medicine basically will make rich white folks healthier. It will probably do little to, in fact, maybe exacerbate health disparities, because poor people, Black and brown people, aren't going to have access to it. And certainly across the globe, poor nations such as those in Africa and Southeast Asia aren't going to have access to it, which will again exacerbate health disparities. So the solution here is not the technology, but it's the social structures in which the technology is deployed. So while I do this kind of research, I understand that doing this work without just societies to apply it in is only going to make the situation of the poor worse.
Thank you. We have a question from Clark McCain, who asks, as it is unavoidable that humans will reach for categories in their attempt to understand the complex world, which categories of human existence would you suggest we employ, recognizing that so many categories are based on falsehoods?
And no one, I don't accept that as a premise. Okay, it's often claimed, oh, the human mind unambiguously and must, use categories. Based upon what evidence did we accept that? Okay, what we need to do is we, again, start with teaching critical and analytical thinking. And in doing so, okay, we can change the misconceptions that people start with. So it is definitely true that our minds evolved to take shortcuts, logical shortcuts, stereotyping and things like that. But that can be untaught. That can be learned. In other words, we can learn not to think that way. But we live in societies that underscore the worst aspects of the way our minds work and play to those so that they can use that as agents of social control. So again, it comes down to, do you want to live in a society that is fundamentally just? And if you do, then we have to take down the structures of injustice. If those structures were gone, we wouldn't have people whose minds gravitate to their worst possible, intellectual foundations. We could teach our kids not to think that way, But our societies intentionally foster that kind of backwards, damaging thinking, because it's precisely how these people stay in power.
Thank you so much. The next question comes from, sorry, they just shifted on me. Charles Okpotu, what's responsible for the health outcome disparities between European descended Americans and African Americans, given that in your talk you talked about Europeans having a higher possibility of disease from a genetic point of view?
It's because they live in more permissive environments. Okay, and that's why if you look at the quantitative genetic equation, environment is a major factor. Gene by environment interaction is a major factor. Covariance of genes and environment. So if you find people with good genes, but they're always in bad environments, they're going to have a bad outcome. And so what this society has done is taken people who actually have the stronger genetic foundation, but they put them in the worst environment. And that's why they show, these health disparities. So, and again, here's the real test. If again, for people who understand, how you would actually properly do genetics, the only way to determine which aspects of the genetic differences between, say, Blacks and whites in America are actually contributing to health outcomes would be a common garden experiment. In a common garden experiment, you rear both groups under the same environmental conditions. And you have to do that for at least 2 generations to account for maternal effects. So if we were to eliminate structural racism and we allowed people to live in a just, fair society, okay, any genetic variants that were still causing disease, we can say, that variant is one we need to deal with. But until we have a common garden, we cannot separate gene by environment. We cannot separate covariants of genes and environment. And this is the entire fallacy of, genomics of health disparity work. And I pointed this out now for 20 years. And I've said this to the directors of NIH directly, which is why they stopped inviting me to NIH panels. Okay, is that unless you have a common garden, none of the stuff you claim is true. You cannot determine that it's true. You can say it, but you've never done it in a common garden. Now, do we know that this works? Yes, because my research lab and many others have done common garden experiments and measured health outcomes in various different organisms. And guess what? Okay, that's how we determine whether a genetic variant really causes a problem or not. And we found that many of the things that we thought, were contributing to health outcomes weren't once the organisms were grown in a common environment. So until the United States has the moral will to give everybody equal opportunity, which we inscribed, by the way, in the Constitution, until we display that moral will, we will never really know the genomic basis of health differences, because people always are living in these dramatically different social conditions.
Thank you. And I think we have time for one last question before we wrap up this presentation. And this comes from Alex Boyson, who says, can you suggest an intellectual framework to address this new stage in the evolving discourse on racism and its social and systemic basis?
Okay, do we need a new intellectual framework? I would argue no. We actually understand this really well. That's why I took such great offense to that statement that came out of the Department of Education saying that systemic and structural racism isn't real. Okay, it is real. It has been real from the very foundation of this nation. We don't need a new framework to discuss this. Okay, they're trying to change the framework because they don't have a leg to stand on. Right? If you know you're wrong, if you know you've created a society that harms people, that causes them to die, that causes and inflicts pain upon them, and you don't want to change it, you simply say, well, that doesn't exist. It's all in your mind. Yeah, you just perceive racism. It's not real. And you're teaching this pernicious falsehood in your universities, in your courses to your students. Because after all, I mean, everything is fair here. So their whole argument is based upon essentially denying the truth. It is the tactic of the big lie. So no, we don't need a new intellectual framework. What we need is the courage to call these people the liars that they are.
Thank you so much. So that wraps up the first presentation for the conference. What we're going to do now is take a short 15-minute break. We'll return at 11 a.m. For the first panel of the conference. So everybody is welcome to stand up, stretch, go get a cup of water, and come back and join us at 11 a.m. Thank you very much.